Okay, good evening. I'm recording this on Wednesday evening, January the 30th. Hopefully you all were able to stay warm today for your e-learning day, and hopefully you'll be able to stay warm tomorrow as we have another e-learning day. I'm filming this for two reasons. One is that if you were not in class on Tuesday and missed this part of the lecture, it's kind of important. It can also be a little bit tricky in terms of the math that we're doing. Although I'll say the same thing again that I said on Tuesdays, that this is the most complicated math we get. But then also this is being shot so that if you need a refresher on how to do this, you can go back and reference this, because you will need to know this material in order to complete your e-learning assignment for tomorrow, Thursday, January the 31st. A couple things right off the bat that I will apologize for. First of all, the lighting. I'm filming this at my home in our schoolroom, and the lighting is not the best for shooting a video of this type. Also, because our whiteboard is made out of sheet metal, it's a homemade whiteboard, and so the light might reflect somewhat oddly. It might be difficult to see some of the numbers. I'm going to do my best. At the very least, at the end, what I will do is I'll pick my laptop up and I'll try to get you the best sort of shot that I can of our two equations that are up here in the top corner that I'm going to reference here in a second. Secondly, the video quality is just going to be what it's going to be. Again, it's not going to be the best thing that you've ever seen, but hopefully it'll be enough to get the job done. So with that being said, let's just dive into it. So we're talking about the elasticity of demand, which the equation that I'll show again at the end is the percent change in quantity demanded divided by the percent change in price. Now, you all, I'm sure, at some point have dealt with percent change, which, by the way, the triangles just denote change. We went over that in class on Tuesday. You all have dealt with percent change before, I'm sure, at some point in a math class. But just as a refresher, percent change is our old number minus our new number divided by the old number, and then you multiply that by 100 so that we're working with percentages. Now, in your e-learning day assignment tomorrow, as I will always do, I will give you parameters to work within. In other words, I'll tell you calculate the elasticity from $10 to $15, or from $7 to $8. I'll always sort of give you the parameters to work within. So in this case, I'm not going to draw the demand curve, but we will look at a demand schedule that I'll just kind of come up with as we work here. So again, price and quantity, and we'll just do 3 price points just for the sake of expediency. So $1, $3, and $5. And then quantities, again, we'll just try to keep it somewhat simple. We'll go 15, 10, and 5. And so if I were to ask you now, find the elasticity of demand from $3 to $5. Okay, so we're trying to find the elasticity of demand, which a lot of times I will abbreviate as E lowercase d. The elasticity of demand from from $3 to $5. Okay, so now we begin working with our equations. The first thing that I would do when faced with this kind of a problem is I would start with price, because that's what's given to me. So I'm going to need to find the percent change in price. So what I'm going to do is percent change in price is equal to, and again I go to this percent change formula. So the old number is the first number that's given. We're going from $3 to $5. I forgot this in class the other day. The elasticity of demand is an absolute value, which I think my second hour group, a lot of you might be more apt to check this out, because we sort of fumbled our way through it on Tuesday in class. One of the things that I forgot to mention is that it is an absolute value function. That's going to get rid of a lot of negatives. It's going to make things a lot simpler here when we get to the end. And again, that's something that we'll come back to. So percent change in price. My old number, we're going from $3 to $5. So we're going to start 3. We're going to subtract our new number, which is 5, divided by the old number, which is 3. Okay. Again, I told a number of you in class on Tuesday, I am very meticulous in terms of the math because I am very prone to making very simple mistakes. And so you'll notice that I am very, very particular about the way that I show my work. The expectation is that you need to be able to demonstrate to me that you know what you're doing. You don't have to necessarily be as meticulous as I am being. Okay? So we're then going to multiply that by 100. When we carry our math down here, 3 minus 5 is negative 2 divided by 3 times 100. I have my calculator in my pocket, which is my phone, but I don't really need to pull it out here because I know that 2 divided by 3 is going to be about 0.67. So it's going to be a negative 0.67 times 100. And we're eventually going to work ourselves out to where we have negative 67. Okay. And so what I'm going to do, just because the space that I have here is not quite as expansive as I would have at school, is I'm going to erase our demand schedule over here. Although I am going to record that at $3 we have a quantity of 10, and at $5 we have a quantity of 5. Again, I'm just doing this because I don't have as much space as I would at school. Because what I'm going to do now is I'm going to rewrite that elasticity of demand equation. Only now I can write, instead of percent change in price, I can plug in now this negative 67. Okay, I'm going to leave that top part blank because we're now going to do percent change in quantity demanded. Okay, so once again we're going to do that percent change equation again. Only this time we're going to do percent change in quantity demanded. And again, we're going to go back to the original or the old and the new values. So we're doing percent change in quantity demanded. Our old number is going to be the quantity demanded that corresponds to our old price, which was $3. So that's going to be 10. So we're going to have 10 minus the new number. Again, the new quantity demanded is going to be the quantity that corresponds to the new price point, which is $5. So that's going to be 5. And we're going to divide by 10. And then we're going to multiply that times 100. Once again, very meticulous. So we're going to work our way down. 10 minus 5 is going to be 5. Divided by 10 times 100. 5 divided by 10 is going to be 1/2. So 0.5 times 100. And that is going to give us a value of 50. Okay? And so once again, we come back over here to our elasticity of demand equation, and we're going to plug in a value of 50. Now, it's at this point that we're going to erase our percent change in quantity demanded that we worked through. Now is where I'm going to have to pull out my calculator, which again is my cell phone, and I'm going to very quickly take 50 divided by 67. Again, this is an absolute value, so the negative does not matter at this point. We can drop the negative. And what we find is that the elasticity of demand for this product, which we didn't even label, normally that would be a very bad economics teacher moment, but for the purposes of this demonstration, that's fine. The elasticity of this demand for this good comes out to be 0.74. Okay. Now, what does that mean? Well, again, for those of you who are not in class, or for maybe those of you that were in class, but maybe by this point, found that this was just too intimidating, what does this number mean now? Well, we talked about 3 different states of elasticity. We talked about elastic, inelastic, and we talked about unitary elastic. Okay, and all three of these different elasticities are relative to the number 1. So a good is elastic if the elasticity is greater than 1. Okay, and again, I'm not going through the notes here with you in terms of the definition. So those of you that were not in class on Tuesday, this is a little bit sort of off the cuff. You would need to get this later, but goods that are elastic respond dramatically to changes in price. Okay? And those are goods that have an elasticity value of over 1. Goods that are inelastic have elasticities of demand that are less than 1. So in the example that we just worked through, we would find that this good is an inelastic good. What kind of goods are these? Well, these are goods that do not respond greatly to changes in price. A lot of the examples of inelastic goods, and it's a lot easier to think in terms of inelastic goods. Goods that we discussed in class, I know in 5th and 7th hour, that are inelastic would be things like gasoline. If you have a car, you have to have gas. You don't have very many other alternatives. And for the purposes of the Learning Day assignment, you don't need to know the 4 factors that affect elasticity. But what we talked about was you don't have any alternatives. If you have a car that runs on gas, you have to have gas. We talked about gas. We also talked about sort of addictive habits. If you know anybody, like I know I talked about, we talked in class about those who maybe smoke. If you are someone who smokes, that's an addictive habit. It doesn't really matter what the price is. If you have that habit, you're going to pay whatever price is demanded. But it doesn't even have to be with something like cigarettes. It could be something. It could be something like caffeine. If you think about coffee, how many millions of people a day have to have coffee to start their day? For a lot of those people, especially those who maybe get coffee maybe at Starbucks or McDonald's, if the price of their coffee goes up by $1, are they still going to be willing to pay for it? Well, probably, because caffeine is an addictive chemical. And so addictive habits don't change very well to price. They don't respond very well to price. So those are your inelastic type goods. Elastic goods are essentially anything that's not elastic, that's not inelastic. Anything that responds greatly to a change in price. The last one is unitary elastic. These are somewhat difficult, but these are goods whose elasticity is exactly equal to 1. Again, we don't see these very often, but it is a condition that you will run into occasionally, and we'll talk a little bit more about that at some point here in class. So, again, most of this is just going to be for running through the formulas. So again, what I will do here now to sort of sum up is I'm going to take the laptop up and I'm going to give you a good 5-10 seconds to where you can really get a good look at those 2 formulas that are so important to completing this assignment. I think that's a pretty good shot. I apologize once again for my chicken scratch, but for those of you that have had me in class a number of times, that's probably not going to be anything that's unfamiliar to you. So with that, I'm gonna go ahead and call it a night in terms of this particular video. If you need any help tomorrow, please make sure you email me. As I'm sure most of you, I'm not going to be going anywhere tomorrow. So I should be pretty responsive, and hopefully we'll see you on Friday.